So in this video, we're going to be learning how to use the Sentinel Modbus to pull Modbus registers from a Modbus sensor. So let's get into our Sentinel Modbus configuration. Now, right now, I have my Sentinel Modbus connected to a Modbus sensor, and I want to be able to pull certain registers out. So the first thing that we need to check is to make sure that the Modbus ID of the Sentinel Modbus is the same as the Modbus sensor. They need to match. My Modbus sensor's ID is 4, so I'm going to put in 4 right here. I'll click on set. Now I'm going to go look at the settings. So the baud rate, the UART mode, the command timeout, and the command pause should be the same. This is for synchronization because if they're not synced together in a similar manner, then you won't be able to get data. There will be miscommunication between the two. So it doesn't necessarily matter what you set the baud rate to, as long as they're both the same. The UART mode, usually in the manual, will tell you what the UART mode or the parity should be. You should get that information from the manual. As a standard, it's 8N1. And also as a standard for the command timeout and the command pause, you should have 1,000 milliseconds for the command timeout and 100 for the command pause, 100 milliseconds, excuse me. So those are set. We have those all good. Now, let's say I want to pull the Modbus register that shows me the value of the supply voltage of my sensor. For my given sensor, it is 1146 for the register address. So the function code is 3, which if you click on this drop-down menu here, you have up to 5 function codes. Coil and read discrete input, function code 1 and function code 2, are the same in that they both read discrete inputs, either a 0 or a 1. Most of the time, you'll want to look at either function code 3 or function code 4, more often function code 3 if you want to pull a register to read. Function code 5 allows you to write a coil, which is just a single bit, whether it's 0 or 1, allows you to write that over. But for our purposes, we want to pull a certain Modbus register that reads the supply voltage, so we will do function code 3. The register address is 1146. Now the count is essentially the number of registers that you're trying to pull. In our case, it's just one register, so we would just do 1. Once that we have that settled, we go down to write steps to Sentinel. This saves what I have just done. And then I click on Run Modbus Program Steps. So the status here will show passed. Now, in a worst case scenario, it'll say timeout, in which case some troubleshooting will be required. If it says exception, that's better. That usually means that it's talking, but you're basically telling the Sentinel Modbus to look in the wrong place to pull the registers that you desire. But obviously, the best status that you want to look for is passed. That means it's properly communicating, it's properly pulling the correct register. But if you want to validate, all you have to do is hover over past the status, double click, so a little window will pop up with the data type of the register address that you're pulling, and the register value. Now, do keep in mind, this data type here is only for debugging purposes. Whatever different data type I select here, it will then translate that register address to the corresponding value. That is not part of the settings. That's not configured for the settings. That is only for debugging purposes, for the user to validate if they are pulling the proper register and reading the proper value. In my case, it is a 16-bit integer or unsigned integer. So I am reading 12 volts for the supply voltage, so this is correct. Of course, if I were to go to float, for example, let's say 32-bit float and run, it'll correspond to a different value. Of course, that's not what I'm looking for. If I were to go to 16-bit unsigned integer. It'll show me the right value. So this is just kind of a way for me to understand that I am pulling the right register and the right value. These settings right here, these correspond to the rearrangement of bytes and bits within the register, and that also corresponds to a different value. With some devices, you will need to configure this. However, as a standard, uh, usually you will want to see high word, high byte, which is in the order of A, B, C, D. So most of the time you won't need to change it, hopefully. So now, of course, we're reading 11.99 volts, which is still within the 12-volt range, which is what I am expecting to read. And just as an additional example, let's say I want to read a relay state. Now, I mentioned before, for a relay state, it's either a 0 or a 1, so we'd want to look at function code 1 or function code 2. However, for my specific Modbus sensor, it requires function code 3. So I'll just do function code 3. The register address to read one of the relays is 1114. Note this one, it's just one register. Next steps. I'm going to run it. So it passed. If I open that up, so the register value is 0, so it is de-energized. Again, I can change it to whatever values. Of course, with some it'll stay the same, at least in the case of a 0. I can move these around. Of course, for the case of the 0, it'll stay the same. Now, let's say I want to read. Let's say I don't want to put in several different registers all at once. Maybe I want to, in one cell, put in a register and then say, read me a whole array of registers. And I don't want to use up all of the cells. I could just say, for example, let's get rid of this. I want to read a number of relays. So I want to read a number of relays starting at a register just 1114. And I want to read the 2 after that in addition. So in total, it would be 3 registers. So I'd be reading 1114, 1115, and 1116. I could write, run. Okay, so now it's passed. So now look at that. Now we're reading registers from 3 different relays. I got 2 that are de-energized and 1 that's energized. Now, of course, I can always move around the data type just for debugging purposes. See that? So now the value's changed. At the end of the day, no matter what data type you set these registers to within the SignalFire network, that has nothing to do with what you will need to program your PLC to. You need to tell the PLC to have a specific data type that you are looking for when pulling these registers, completely separate from whatever data type you set to with the SignalFire equipment. The PLC will not understand what the SignalFire equipment has set the data type to. And that's basically all that there is to know, at least with respect to pulling Modbus registers using the Sentinel Modbus.